Hello, fellow electrical hobbyists. It seems like just about everybody has their own version of a home-built DC motor up on YouTube. There are hundreds of videos, and I'm not going to be any exception. Today I'd like to show you my latest project. It is a home-built DC motor. It's a 2-pole motor, and it has its own onboard battery pack power supply. I think my motor is somewhat unique because of my brush commutator assembly. It's something I haven't seen before, and possibly you haven't either. This motor meets my two basic requirements for a home-built DC motor. Number one, it is always self-starting, does not need any prodding or encouragement. And number two, it actually develops enough torque that it could do some useful mechanical work if I wanted to hook it up that way. Let me show you the materials and how I built my motor. The armature, of course, is standard 1/2-inch PVC tubing. I'm using two pieces of tubing connected by a coupling. This gives me some level of adjustability between the position of the coil and the position of the commutator. This is done with a simple twist. Later on, you can use this adjustment to make the motor self-starting. And then, of course, the PVC armature has to have two end caps. And making the end caps is kind of tricky. They have to be precision drilled in the dead center and perfectly straight to accept a press-fit nail. This is not especially easy to do. In fact, I bought about a dozen end caps, and it took me about a dozen tries to get two that were perfect. As you can see, this is one of my failed attempts. And then, of course, after you have two perfect end caps made, there is another precision drilling job. The armature is held in place with two 3-inch steel angle brackets, and the brackets have to be drilled to accept the nails. The hole cannot be too large, or the armature will wobble. If the hole is too small, the armature will bind. The hole has to be perfectly straight and just a hair larger than the diameter of the nail. Again, this is another job that should be done on a drill press. And then we come to making our coil. For my coil, I used a 3 or 4-inch carriage bolt that passes directly through the armature. Drill a hole and push it through. Then I begin winding my coils on one side here. I use just about any gauge of magnet wire, but I put as many turns as possible on one side, remembering to count the number of turns, so I can put an equal number of turns on the other side. It's important to try to keep the armature balanced. Another important thing is to wind in the same direction. If you begin clockwise, you must continue clockwise. Otherwise, your motor will not work. And then we come to the commutator. This is a split-ring, 2-section commutator. Each section is connected to one end of my coil. I made my commutator out of a standard 1/2-inch copper coupling, which I cut lengthwise with a hacksaw, and then I placed each half on opposite sides of my PVC pipe. This makes a very nice commutator. And then we come to the brushes. My brushes are made from household copper screen material. This is household screening made from real copper. Now, you can't buy this anymore. I found a few pieces at a junkyard. Now, in designing brushes, it's very important to have as much contact area as possible, but yet as little friction as possible, creating as little drag as possible. And my arrangement of brushes here, I think, is just about perfect. In fact, I'm so happy with it, I'm going to show you a close-up of a mock-up that I made of the brush assembly. Here's a mock-up of my brush assembly. Here are two squares of copper household screening material that make the brushes. The brushes are soldered to mounting arms, which are made from a very heavy gauge copper wire bent to this specific shape. And the mounting arms are mounted so they can pivot. Now, proper tension is held on the commutator by means of a rubber band that spans from one arm to the other. This makes the tension on the two brushes perfectly equal and is also adjustable simply by changing rubber bands. You have to imagine the commutator going in here. And finally, we come to the permanent magnets. These magnets should be as strong as possible. In fact, I invested in 2 neodymium magnets from a place called K&J Magnetics that you can find online. Neodymium magnets are extremely powerful, but a little bit expensive. If I remember right, I paid close to $16 for each one. These magnets are so powerful that once I let them contact my steel angle bracket, I couldn't get them off. In fact, I can't move them now. I think they are permanently mounted. However, this is exactly what you want for a very powerful, efficient DC motor. I'm glad I bought them. I wanted this motor to be as small and compact as possible, so I gave it its own battery pack. I have 4D cells here, which provide 6 volts, and the motor runs quite well on 6 volts as you have seen. However, I've also hooked it up to my laboratory DC power supply and run the motor at up to 24 volts. And at 24 volts, it really zooms along. I'll show you what I mean. Okay. Now I've removed the 4D cells and hooked my motor up to my DC power supply. The power supply is now set to 0 volts. I'm going to slowly increase the voltage and call out the numbers as we go along. Here goes. 4.6 volts, 6 volts, 8 volts, 10 volts, 13 volts, 15 volts, 18 volts, 20 volts, 23 volts. Coming back down again. 10 volts. 6 volts, 3 volts, motor is still operating at 3 volts, 1.7 volts, still turning. As always, when I build a project, I like to make something with some lasting value, something of quality, and this motor is no exception. I began with some research, some experimentation, and a lot of trial and error before I came up with this configuration. And looks are important too. My wooden base is painted black, and my angle irons are painted bright red. This gives the motor kind of an important electrical appearance. I think this motor would be a great teaching aid in any science classroom. First, it demonstrates the principle of electromagnetism, and it demonstrates how electricity is converted to mechanical or kinetic energy. And of course, these are 2 very important principles we come across daily. Well, that's all I have for now, folks. I thank you for watching, and I'll see you next time.